Video we will look into some of the various options or approaches which we can use to generate a unique ID in a distributed system. So in total, we will discuss about number one, let's say multi-master replication. Two is universal unique ID generator. Three is ticket server by Flickr. And the fourth is Twitter Snowflake approach. So we will deep dive into each of them individually and look into how they generate the unique ID and what are some of the pros and cons for each of these individual approaches. So let's first look into our first approach, which is multi-master replication. So as the name suggests, we have multiple master nodes. Let's say suppose node 1, node 2, all these are master nodes, and data is being written into these multiple master nodes. We write data in all these nodes, and eventually this data is being replicated into these servers through their internal synchronization and other approaches which they use. To learn more about these details, you can look into my data replication video under the series Design a Key Value Store, about which I will put the link in the description. So in this high level view, just understand that we write data into multiple master nodes in a distributed system, and eventually this data is replicated into these multiple nodes. So data is replicated into these nodes eventually. So now suppose we have to generate unique IDs for each individual data, and it should also be taken care of that there are no duplicate IDs for two different entries. Suppose I write one data in node 1 and its unique ID, let's say, is 5, and simultaneously another data is being written into node 3 and it generates also 5, and both these data are different but the unique ID is same for both. So this should not happen. For this, what we use in this multi-master replication is we use auto increment with two things. One is offset, another is increment. So offset is basically the starting unique ID value. Let's say suppose we denote this with the ith node. So ith node will have this offset of I. So for node 1 the offset would be, let's say, 1, for this offset would be 2, for this offset would be 3, and the increment would be equals to the number of multiple master nodes. So let's say here it is, so let it denote by k notation, and let's say here it is 3. So basically increment here would be 3 in all the cases. So how the data will be generated is like in node 1 it will be like 1, 4, 7, 10 like this. Here it would be like 2, 5, 8, 11 and like this, and here it will be like 3, 6, 9 and 12 and like this. Okay, so you can see in each individual node unique IDs are being generated. So here we actually use two things: auto increment with offset and auto increment with increment. Increment takes the value of the number of multiple master nodes in which we write our data, and the offset is basically the starting value of that particular node, which is the node number in our case. But there are certain cons or drawbacks for this approach. One is like it's very hard to scale with multiple data centers. So as you can see, there needs to be a synchronization between all the nodes to collect the data, like number of nodes in which the data are being written, like now in how many nodes the data has been replicated, what is their offset, and all those data has to be is required for each individual node. So there has to be a synchronization between all the nodes, and thus it incurs latency and it's very hard to scale. So it requires coordination between all the nodes. This is one of the major drawback, and it does not very much scale. So whenever a new server is added, or removed, the scaling is not very much efficient. So as you can see here also in the example, suppose I was following this approach with offset and increment of this, and another server is now added into another node, 4 is added. So all I have to do is I have to increment this value to 4, and all those values which will be generated here, let's say, and I have to also set up this individual value of this offset also, is it's the node 4's offset I have also to set, or else the 4, if I start with the 4, then it will cause a collision for both the two different datas with same unique IDs. So all these things have to be taken care of, and so it is very much not efficient to scale whenever a server is added or removed. So these are some of the cons which we can, drawbacks which we can see for this method. So next let's discuss about this universal unique ID generator which we have mentioned. So this unique ID generator is basically a 128-bit number, 128-bit value. So it can be both number plus string combined. Since it's 128 value, so it's very difficult for any unique ID generator to have collision, because the values are already unique. And if I quote Wikipedia, if you go through Wikipedia, it says like, after generating 1 billion of universal unique IDs every second for approximately 100 years, the probability of creating a single duplicate would reach 50%. So you can see that by this figure how much it's very much efficient to generate a universal unique ID of 128-bit value. These are basically generated by, so unique IDs can be generated by either by web server or database server. So but to reduce latency and to reduce the time, what we usually follow the approach is like we generate the unique IDs in web server itself. So the universal UUIDs or universal unique identifiers are generated in the web server. So it has a number of advantages. These are number of pros or advantages as we can discuss, as you can see. So one is like it's very simple to generate, and unlike the multi-master replication method which we just discussed, no coordination is required because each individual web server generates its own UUIDs. And as you have also, I have quoted from Wikipedia also, as you can see the number, it's like it takes a large volume of UUIDs to generate in order to have a collision. So no coordination is necessary. But one of the cons which we have here, and which is not aligned with the requirement, is like it is 128-bit value, and it can be both numerical plus string. But our requirement was like 64-bit. This was our requirement. So this is one of the drawback which we have. And this is another drawback, like which I just discussed, like it is not only numerical, it is also numerical and string combined, but our requirement was numerical. So these are the two approaches which we use, which we discussed about their pros and cons for unique ID generation. So in the next video, we will look into the ticket server designed by Flickr and ultimately the Twitter Snowflake approach, which we use for a unique ID generation. So thank you for watching this video. See you in the next video.